Good morning, Ignite students. Welcome back to Earth Science. Here's another video. We're going to be talking about a couple things today. Specifically, let's go back and look at some of the things we've already done. You've defined some of the major branches of Earth science, the difference between meteorology and astronomy and oceanography, and you've done all of that. You've looked at the four spheres: the geosphere, the biosphere, the hydrosphere, right, and the atmosphere. Big thing, we need to get not just a definition of what that is, but how do they interact. There's a side assignment for you to look at today about Hurricane Laura since it's raining outside. That's one assignment. Second thing you should be looking at, there's a Quizlet to practice. It's going to help you see how those spheres interact with each other. So you've done all that. You're good up to there. The carbon cycle. I'm sure you're good with the water cycle. That you've been doing that for years. The carbon cycle. We're going to divide it up a little differently. If you watched the videos from online from the other day, we're going to talk about it a little differently today. First thing, we're going to divide it two things. There's the slow carbon cycle and there's the fast carbon cycle. Okay, so they can break it up all sorts of different ways. We're going to think about it as slow and fast because the slow has a loop and then the fast has a loop. And while they interact, they're kind of closed loops. Each one syncs with itself. Okay. Slow. How slow is slow? Okay, the sloths on, what is that, Zootopia and the DMV or whatever that, I don't know, whatever. The slow carbon cycle, hundreds of millions of years to complete. 200 million, 300 million, 100 million. Rock, soil, ocean, atmosphere. Carbon moves through all of those things very slowly. We're going to start with the atmosphere. There's carbon in the atmosphere, not just CO2, but there might be small amounts of elemental carbon or bicarbon or whatever in the atmosphere. Rainwater mixes with that carbon and you get carbonic acid. Carbonic acid, generally pretty weak, but it rains. And so you get acid rain. When there's smog, when there's a lot of pollution, it can go up a lot. Like the strength of this and all that can increase significantly. But carbonic acid's not that bad. It comes down in the rain, but it dissolves rock. Like real rock, like not just limestone, like building facades. It dissolves rock. That is chemical weathering. There's another word for us. There's a vocab. Chemical weathering is acid rain dissolving the rock. When it dissolves that rock, minerals get broken down and they leach out. They come out into the water. The minerals that were already in the rock: calcium, magnesium, potassium, sodium. Some examples, okay? But minerals, elements that are already in the rock, are broken apart and released when the acid rain falls on it, okay? Rain runs down into the stream, into the ditch, into the stream, into the river, into the ocean. Those minerals get taken with it. The calcium, specifically the magnesium, the potassium, the sodium, they go with this river water all the way to the ocean. In the ocean, we're going to talk about the calcium. You're like, I thought we were talking about the carbon cycle. Well, the carbon cycle is built into all this because it's not pure calcium, okay? The calcium and bicarbonate mix together and they make calcium carbonate. Calcium carbonate, it's chalky, it's Tums, okay, or antacid. I can't say a brand name, right? It's an antacid. It's very common. It changes pH very easily. It neutralizes acid. It does several things, okay? So that is used by animals to make shells in the ocean, right? Those animals die. They sink to the bottom. You get layers and layers and layers and layers, and over millions of years, now you get a rock like limestone, okay? So now that you've built that rock back